All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about chemical reaction, right? But we'll be talking about redox reaction in particular, though we have different types of chemical reaction, right? If today is the first day of watching our video, please click the subscribe button, right? Chemical reaction involves the formation of new substances, okay? The formation of new substances as a result of chemical changes. When there is a chemical change, it will bring about another substance, and that is what is called chemical reaction. We have different types of chemical reaction. We have the combination reaction, the displacement reaction, the decomposition reaction, the double decomposition reaction, the catalytic reaction, the reverse reaction, the thermal decomposition reaction, and or thermal dissociation reaction. Sorry, thermal dissociation reaction. And though we have thermal decomposition reaction, if a compound is decomposed through the application of heat, we call it thermal decomposition of reaction, right? Or thermal decomposition reaction, right? Then the last one is the redox reaction. Please go and learn these different types of reactions. The main one we want to talk about is redox reaction. And redox reaction is the reaction that involves oxidation and reduction, right? So you write oxidation and reduction reaction, right? These are two opposite processes, but they are complementary. In other words, every oxidation must be accompanied by reduction, right? Then definition. Now, in definition of oxidation reaction, oxidation and reduction reaction, we define it in different terms, right? Oxidation and reaction can be defined in terms of, number one, we can define it in terms of oxygen, in terms of hydrogen, in terms of metals, in terms of non-metals, and in terms of electronegativity, in terms of electropositivity, and then in terms of electron transfer, right? But the generally accepted definition of a redox reaction is in terms of electron transfer. All right. So let's talk about the first one in terms of oxygen. In terms of oxygen. Now, from the word oxidation, we are talking about oxidation and reduction. So we are talking about oxidation and reduction. Oxidation and reduction. Okay. Now, let's define oxidation and reduction in terms of oxygen. In terms of oxygen. Sorry, oxygen. Now, from the word oxidation, you will know that oxygen is involved. So, oxidation is the addition of oxygen. All right, the addition of oxygen, while reduction is the removal of oxygen. All right. So, for example, if I have this reaction, let's consider this reaction 2 MgO plus S, okay, to give SO2 plus Mg. All right. Now, if you look at this, you will see that that this particular one added oxygen. If you look at this, you see that this was single before, okay? It was without oxygen before. Then the next thing we are seeing is what? Oxygen is added. So S to give us SO2 means oxidation. All right. Then 2 MgO that has oxygen before loses the oxygen to become Ng is what gave us reduction. As simple as that. All right. Now the next thing we look at is oxidized species. Now, if you look at this, you will see that this one was the one that oxidized. Oxidized means addition of oxygen. All right. You will see that S is called oxidized species. Oxidized species. And another word for oxidized species is called reducing agent. Okay, please note that. Another word for oxidized species is reducing agent. While another word for reduced species is oxidizing agent. Okay, this is oxidized species, or you call it reducing agent. Reducing agent. Now, most of the time, students get confused. They want to call reducing agent or oxidizing agent. Please, if you are asked to find reducing agent, please don't find reducing agent. Just go and find oxidized species, because from the word reducing agent, you will think that you will get it from reduction. Okay, you will not make mistake. So please, anytime they ask you oxidizing agent, just forget about it. Go and get reduced species from reduction. From reduction. Or if they ask you reducing agent, just go and get oxidized species from oxidation. All right, that is just how to know it. Now, if you look at the next one, 2MgO had oxygen. In fact, 2MgO giving Mg was the one that undergone reduction. So therefore, that 2MgO is what is called reduced species. All right, reduced species. And another word for reduced species is what? Oxidizing agent. Oxidizing agent. Okay, so now if I'm being asked to find oxidizing agent, do anything agent leave agent, please. Anything agent leave agent. If you hear oxidizing agent, just remember that oxidizing agent is the same thing as what? Reduced species. So reduced species is gotten from reduction, so that you don't make mistake. All right, so the next thing we'll now talk about is their product. So if you look at this gave us this, so therefore, and it's oxidation, so therefore SO2 is what we called oxidation product. Okay, oxidation product. Oxidation product. While this one Mg is what we now call reduction product. Reduction product. All right, so this is very, very simple. So let's move to the next one. The next one we are moving to is in terms of hydrogen. We have talked about in terms of oxygen. In fact, redox reaction is just a reaction that involves hydrogen and oxygen. Okay, in a way, that is a specific part of it. So in terms of hydrogen, let's talk about in terms of hydrogen. Now, if you remember that oxidation, from the word oxidation, so oxidation is the addition of hydrogen and then addition of oxygen, from the word oxidation, but removal of hydrogen. So reduction is now removal of oxygen but addition of what? Hydrogen. All right, you need to know that, very, very important. So oxidation is now the removal. Since oxidation is the addition of oxygen, it is now the removal of hydrogen. Then since reduction is the removal of oxygen, it is now the addition of what? Hydrogen. So if you have a reaction like this, you have a reaction H2S plus Cl2 to give us 2HCl plus S. Now if you look at this one was with hydrogen before. Okay, then H2 had hydrogen before, then producing just S without hydrogen. What do you call it? So this is removal of hydrogen. So since it is removal of hydrogen, we call it what? Oxidation. Okay, now Cl was without hydrogen, and then he now got hydrogen as the result, HCl. So this one is called what? Reduction. Very simple. Now, don't forget that if they ask you agent, we don't need anything agent. So if they ask me oxidizing agent, I don't need oxidizing agent. I will just know that oxidizing agent is the same as what? Reduced species. Are you getting it now? So if they're asking me reducing agent, we know that reducing agent is the same as what? Oxidized species. So from oxidation, we will now see that what? H2S, who undergone reduction, oxidation, will give us what? This thing is what? Oxidized species. oxidized species. And another word for oxidized species is what we now call reducing agent. All right. So now look at reduction now. Cl2 was the one that undergone reduction. So we have it as what? Reduced species. Reduced, sorry, oxidized species. Reduced species. All right. Or another word for reduced species is what? Oxidizing agent. So please, anytime they ask you agent, look for the other one, because if you want to find the agent by yourself, like trying to find reducing agent, you will not think that it is gotten from reduction. You will make mistake. So instead of finding reducing agent, please find oxidized species. Oxidized species is something as what? Reducing agent. So now the result of oxidation is called oxidation product. So S is what? Is oxidation product. Oxidation product. All right. Then which one again? This one, 2HCl, is now my reduction product. Okay, so that is that for that. So the next one we'll talk about is in terms of metal and non-metal. In terms of metal and non-metal. Number 3, in terms of metals and non-metals. All right. Oxidation is defined as the addition of non-metal and the removal of metal, while reduction is the addition of metal and removal of non-metal. Please take note of that. If you can remember, okay, yes, oxidation is what? The removal of non-metal. The removal of non-metal, while reduction is the removal of metal. Take note of that. So the next one we'll talk about is in terms of uh, electron transfer. Okay, in terms of electronegativity and electropositivity. Electro electro electronegativity, electronegative, and electropositive. Okay. All right. Right. Oxidation is defined as the addition of electronegative elements and the removal of electropositive elements, while reduction is the removal of electronegative elements and the addition of electropositive elements, as shown below. Now, if I have two FeCl3 plus H2S, right, to give us 2FeCl2 plus S plus 2HCl. All right, you will see that 2FeCl3, this one reduced to this. Okay, from this to 2FeCl2 is what is called the reduction. I'm coming to that. Okay, don't forget that what? Reduction is the removal of electronegative element, right? Reduction is the removal of electronegative element. Yes. Okay, reduction is the removal of electronegative element and the addition of electropositive element, while uh, oxidation is the removal of electropositive element and the addition of electronegative element. All right. So we have that this one H2S to give us where is the H there? To give us just S, right? It was with hydrogen, and then we now have S. In fact, if you look at this F, you will see that This one was with hydrogen before, and then he lost that hydrogen. So, and the loss of hydrogen is called what? Oxidation. Don't forget. So it's even very obvious, even uh, without knowing the electronegativity and positivity. You will just know that this one is oxidation. Oxidation. All right. Since it's oxidation, from here, once you have gotten the one that is oxidation and the one that is reduction, then getting every other thing is very simple. So the first thing you can get is what? Oxidizing agent. And I told you, if they're asking you oxidizing agent, please don't look for agent, look for the other one. And you know that what? Oxidizing agent is same as what? Reduced species. And this one that undergo reduction is called the reduced species. So 2FeCl3 is what? Is the reduced species. Is the reduced species. And reduced species is something as what? Oxidizing agent. All right. So this one that undergone oxidation, that is H2S, is now what? The oxidized species. Oxidized species. All right. As well as what? Reducing agent. Okay, very very simple. And then their product is now the reduction product and oxidation product. So 2FeCl2 is now what? The reduction product, while my S is now what? The oxidation product. Oxidation product. All right. So as simple as that. All right. To recognize oxidizing and reducing agent in the reaction above, right? In this type of reaction above, one need to study or know electronegativity and electropositivity, right? Electronegativity and electropositivity. So let me show you about electronegativity and electropositivity. Now, uh, now for elements, for metals, or let me talk about non-metals first. For non-metals, electronegativity decreases from fluorine to phosphorus. Yes, from fluorine to phosphorus. We have fluorine, oxygen, chlorine, nitrogen, bromine, uh, carbon, iodine, and phosphorus. Right? So now, this one, electronegativity increases from here. Okay, so this, let me just draw like this and say that what? Electronegativity decreases. Okay, it decreases down this way. So you need to know this element: oxygen, fluorine, oxygen, chlorine, nitrogen, bromine, carbon, iodine, and phosphorus. So but for metals, we have potassium, sodium. um Potassium is the most electropositive element. So is it abi the least electropositive element? No, the most electropositive element is potassium. Yes. Ca, magnesium. So the most electronegative element is who? Is fluorine, please. That is the highest. So we have Mg, aluminium, zinc, iron. uh what's Pb? Can I remember? Copper. I think Pb is lead. Yes, Pb is lead. Okay, so and the electropositivity decreases down this. Electropositivity, electropositivity decreases. All right, so that is that. So the most electropositive element we have is what? Is potassium. So the next one we'll talk about, in fact, the more to study this thing more, you need to you need to study this type of reaction, displacement reaction. Yes, because elements that are higher, that is more electronegative, will displace those ones that are less electronegative, because fluorine will displace chlorine in their compound. Because why? Fluorine is more electronegative than chlorine, something like that. So just study the other type of displacement reaction. Displacement reaction, it will teach you that very very well. All right, but that is not the main thing. We are here to do calculation on redox reaction, but I'm just preparing your mind. So the next one, I think number 4 or number 5, I cannot remember, is in terms of electron transfer. In terms of electron transfer. Okay, so right, the most generally accepted definition of oxidation and reduction is in terms of electron transfer. Oxidation is the loss of electron, while reduction is the gain of electron. Okay, oxidation is the loss of electron, while, in fact, you know that loss of electron shows metal. So oxidation, oxidized species are metals, while reduced species are non-metals. You need to take very note of that. Okay, so now, right, uh, what did I say? Oxidation is defined as loss of electron, while reduction is gain of electron. All right, reduced species, which is also known as oxidizing agent, is the element that accepts or receives electron. In other words, oxidizing agent or reduced species are receivers or acceptors of electron, while reducing agent or oxidized species is an element that donates or loses electron. Therefore, oxidizing agent or reduced species is the donor of electron. Right? Note that metals loses electron while non-metals gain electron. Therefore, metals are oxidized species as well as what? Reducing agents, while non-metals are what? Reduced species as well as oxidizing agent. So I have this. They said that 4Fe FeO, all right, plus O2 to give us 2F, to give us 2Fe2O3. This one is solid, uh this one is a gas, and this one, another one, is equally solid. Now, if you notice what happened here, you will see that this is 4Fe 2 plus. Okay, then oxygen here is 2 minus, so that it will cancel out. Okay, plus oxygen here is not combined, so it is 0. Don't forget, I told you that in their free state they are 0. Okay, then to give us 2Fe, they have to change. That is why you have 3 here and 2 here. So this one will now be 3 plus, while the oxygen will now be what? 2 minus. Are you getting it? So that is what happened here. So now, what do we do? So from here, it is very obvious to see that Fe2 plus became Fe3 plus. All right, Fe2 plus became Fe3 plus. So what does it mean? It means that that this one undergoes what? This is, he lost 1 electron here to become 3 plus. Okay, look at that. He was 2. He was 2 here. Then he gave somebody 1 electron. That is why he became 3. Fe3 plus. Okay, but look at oxygen here. O2 minus. Sorry, oxygen was 0 here. Sorry, oxygen was 0 here. Okay, here oxygen was 0. So it was 0. Oxygen was 0. Then, but he now accepted. Sorry, minus, he gave out. So he now accepted how many electrons? 2 electrons to become um, O2 minus. Are you getting it? So what happened? This one gave out. So giving out electron is called oxidation, while receiving electron is reduction. So right, observe that oxygen oxidizes 2Fe2 plus to 2Fe3 plus. Therefore, oxygen is an oxidizing agent as well as reduced species. All right. Like I told you that if you see what happened here is what? Reduction. But what happened here is what? Oxidation. So once you can identify the oxidation and reduction, then every other thing is very simple. So this one that undergoes oxidation is who we call what? The oxidized species, or you call it reducing agent. Okay. Why this one that undergoes reduction, this oxygen here is called what? The reducing species or reduced species, as well as oxidizing agent. Are you getting me? Why their product is now the oxidation product and the reduction product. All right. Right, right. Let me explain it. They said, note the oxidation number of Fe increases from +2. Are you getting it now? To +3. Why? He gave out. When you give out somebody, you are increasing. Are you getting me? Because the person is owing you, but when you receive, you are reducing. So increases from +2 to +3. This means loss of electron equally means increase in oxidation number. So please, increase in oxidation number is equally known as oxidation. Okay, increase in oxidation number is equally known as what? In oxidation. Why decrease in oxidation number is known as what? Reduction. So they said the oxidation number of O2 decreases from 0 to -2. You see, it decreases from 0 to -2. So decrease in oxidation number is called reduction. Are you getting it now? So therefore, oxidation and can equally be defined as increase in oxidation number of a substance, while reduction is equally known as what? Like I said, decrease in oxidation number. So now let's talk about oxidation number and how to calculate oxidation number. Right? Oxidation number. Oxidation number. Okay. All right. Oxidation number is the electrical charge on an atom or group of atoms. Okay, appears to have as described by some arbitrary rules. There are some rules you need to know for oxidation number. Rules of oxidation number. Okay, the first one said that the oxidation number of every element or atom in its free state is what? Or uncombined state is 0. Like we said before, for example, Na standing alone when it is not combined, Mg standing alone when it is not combined, zinc standing alone, oxygen standing alone, chlorine standing alone. They are all the oxidation number of all these elements are what? 0. Why? Because they are standing alone. Number two said the oxidation number of a single ion is equal to the size and the sign to the charge of that ion. An example to that, if I now change this thing to ion, Na plus, the oxidation number here is +1. Mg 2 plus, the oxidation number here is 2 plus. Zn, the zinc there, do I say plus? Okay, 1. Then O2 minus, what does it mean? The oxidation number is -2. And then Cl2 minus, the oxidation number is equally -2. Al3 plus, the oxidation number there is +3, and so on and so forth. Number 3 law said that what? The oxidation number 3 law said that the oxidation number of a group of ion, okay, is the algebraic sum of the oxidation number of each of the components that make up of the ion. For example, if I have SO4 2 minus, okay, I will say that the oxidation number of this is equal to what? We can say that oxidation number of sodium, okay, sodium plus 4 oxidation number of oxygen. Are you getting me? and then when you add it, you should equate it to that minus 2 you are seeing. Are you getting it? So if you sum this one and sum this one, it's supposed to give you minus 2. Are you getting it? In this particular one now, the oxidation number of sodium here is 6. Okay, if you say 6 plus 4 into minus 2, that is 6 minus 8, which is minus 2. I get it. So if you sum this, it's supposed to give you minus 2. So, but if it does not have any ion, we equate it to 0, like we said before. Number 4, the sum of the oxidation number of elements in a compound is equal to 0. Like I said before, if I have H2SO4, for instance, it means that if I say 2 hydrogen plus sulfur plus 4 oxygen, I will equate them to what? To 0, because it does not have any charge. Okay. Number 5, and which is the last one, said the oxidation number of a group of ion is equal to the charge on the ion. Okay, we have said that already. Please note, very important thing to note, that the oxidation number of hydrogen is +1, except in hydrides, where it is -1. It's only in hydrides that we have it as -1. And another one is that the oxidation number of oxygen is -2, except in peroxide, where it's equally -1. So please, you should know these two, because oxidation and reduction is always in terms of hydrogen and oxygen. So these two are very, very important to us. So the oxidation number of oxygen normally is +1. Only in what? Hydride. That is where we have that is equal to what? -1. Are you getting it? So another one is what do I mean by hydride? I think, for example, hydrogen chloride. Is it? No. Please find out some elements that are called the hydrides. Find it out so that I will not make mistake. But I know for peroxide is H2, sorry, is Na2O2. Okay. Sodium peroxide. In sodium peroxide, the oxidation number of oxygen here is what? Is -1. Normally the oxidation number of oxygen is what? -2. Only in peroxide, that is where we have it as a -1. Please take note of that. Very, very important. So now let's start calculating the oxidation number of some elements. Example number 1. Number 1 said calculate the oxidation number of sulfur of S in H2SO4. All right, solution. If you look at this, that this is not an ion, so we say that what? 2H plus what? S plus what? 4O is equal to what? 0. And the oxidation number of hydrogen, I told you, is 1. So 2 in bracket of 1 plus S plus 4 in bracket of oxidation number of oxygen is what? -2 is equal to 0. Remember, they say we should find the oxidation number of S. So therefore, 2 plus S, this time this will give you -8, is equal to what? 0. So S minus 6, this two will give you -6, is equal to 0. So S is equal to what? 6. So the oxidation number of sulfur here is 6. And that is why we call this hydrogen tetraoxosulfate 6. That 6 is the oxidation number of sulfur here. Okay? If you don't want to start with hydrogen, you know that the presence of hydrogen means acid. You call it tetraoxosulfate 6 acid. So that 6 there is the oxidation number of sodium. Are you there? It's sodium, sorry, sulfur, not sodium. Okay? So the next one, number 2. Number 2 said calculate the oxidation number of, okay, I'll just be changing the element. Oxidation number of P, phosphorus, in PO4 3 minus. Right? Solution. Very, very simple. What do? We say that P plus 4 of O is equal to what? -3, because of the ion here, -3. So I'll have that what? P plus what? 4 in bracket of -2 is equal to -3. So P minus 8 is equal to -3. So therefore P is equal to what? minus 3 plus 8, which is equal to what? Plus 5. So therefore, the oxidation number of phosphorus here is 5. So that is why we call it tetraoxophosphate 5 ion. Tetraoxophosphate 5 ion. Okay? Why? Because the oxidation number of phosphorus there is 5. So the next one, they say calculate the oxidation number of Mn in KMnO4 O4. Okay, very simple. We tell them potassium K plus magnesium manganese, Mn plus what? 4 of oxygen is equal to 0 because it does not have any charge. Okay, so what do we have now? Potassium is 2 plus. Okay, that is plus 2. Okay, plus 2 plus Mn plus 4 into minus 4, minus 2 is equal to 0. So what do we have now? Plus 2 plus Mn minus 8 is equal to 0. So therefore, Mn minus 6 is equal to 0. Then Mn is equal to 6. So that is why we call it potassium tetraoxomanganese 6. All right? Potassium potassium is 1, not 2. Jesus. Potassium is 1. So this and this will give you 7 here. Sorry. So I have 7. Yes, 7. All right, so that is that. So it is called potassium tetraoxomanganese 7. All right, so the next one, they say calculate the oxidation number of Cr in in K2 Cr2O7. All right, okay. So what do we say? We say 2 of K plus 2 of Cr plus 7 of oxygen is equal to what? 0, because it does not have any charge. So we say 2 of plus 1 plus 2Cr that I'm about to calculate plus 7 into minus 2 is equal to 0. So I have 2 plus 2Cr then minus 14 is equal to 0. So therefore 2Cr minus 12 is equal to 0. So therefore 2Cr is equal to 12. So Cr is equal to 12 divided by 2, which is what? 6. So that is why we pronounce this thing as potassium 7 is hepta. Yes. Potassium hepta dichromate 7. Is it correct? Let's pronounce it again. Okay, I don't put oxygen, sorry. It is potassium hepta oxide. Hepta oxo. Oxide is oxo, okay. Potassium hepta oxo dichromate 6. Please pronounce it with me. Oh. Potassium hepta oxo dichromate, because the chlorine there is 2. What is it called? It's not chlorine. What do we call that element? Final Cr, chromate. Cr, find it out, Sha. But this is what potassium heptadichromate. Potassium heptaoxodichromate 7. That is it. Okay. So the next one, they say we should find Cr in Cr2O7 2 minus. Cr2O7 2 minus. All right. So that's the last one we're going to solve there, which is 2Cr plus 7 oxygen is equal to minus 2 because of the power there. So what do I have? I have 2Cr plus 7 into minus 2 is equal to minus 2. So therefore 2Cr minus 14 is equal to minus 2. So 2Cr is equal to minus 2 plus 14. So 2Cr is equal to 12. Then Cr will now be 12 divided by 2, which is what? 6. Okay, so the same thing. That is heptadichromate 6. heptaoxodichromate 6. Sorry, heptaoxodichromate 6. All right, note, positive oxidation charge means oxidation, while negative oxidation charge means reduction. All right, so the reactant with positive oxidation charge is a reducing agent as well as oxidized species, while the reactant of negative oxidation charge is the oxidizing agent as well as reduced species. I have explained that before. All right, so oxidation charge is determined by subtracting the oxidation number of the reactant from the oxidation number of the product. Okay, so they can ask you the oxidation charge. Oxidation charge is just by subtracting the product from the reactant. Okay, the oxidation number of the product from that of the reactant. That is what is called oxidation charge. Please write it down. Oxidation charge. All right, is equal to what? Oxidation number of product minus oxidation number of reactant. Okay, very, very important. So let's do that. So we have that example. They gave us 2p 3 minus plus 3s to give us 2p plus 3s 2 minus. Then I say determine the following: number 1, oxidation; number 2, reduction; number 3, please write it down. Determine number 1, oxidation; number 2, reduction; number 3, oxidizing agent; number 2, reducing agent; number 4, oxidation product; number 5, reduction product. So what do we do here? This is very simple. You will see that this man was -3. The reactant, this is 2p 3 minus, that gave us 2p. This is from -3 to 0. So was it increasing or decreasing? You see, it was increasing. From -3 to 0, it was increasing. So since it is increasing, so increase in oxidation number is what we call oxidation. So this reaction is oxidation. So look at the other one now. 2s to give us 3s 2 minus. This one was 0. It now decreased to -2. So decrease in oxidation number is what we call reduction. All right, they are now asking us oxidizing agent, and I told you, please, you don't have any business with agent. So if you have oxidizing agent, is as good as what? Reduced species. So therefore, this man that undergone reduction is where we get our reduced species from. So therefore, 2s which undergone reduction is my what? Reduced species. And reduced species is same thing as what? Oxidizing agent. All right, so now from oxidation, we now have that 2p 3 minus, which undergoes oxidation, is my what? Oxidized species. If you don't want to call it oxidized species, that is where you now call it reducing agent. You see, this is very simple. Then their product 2p is now what? Oxidation product, while 3s 2 minus is now what? The reduction product. So another thing they can ask you to find is the oxidation charge. For this first one, the oxidation charge here is what? From 0 minus into -3, which will give you what? +3. So oxidation charge of this is what? +3. Then for the other one, the oxidation charge there is what? -2 minus 0, which is what? -2. You see, so positive oxidation charge is what we call oxidation, while negative oxidation charge is what we call reduction. Are you getting it now? So very, very simple. So we can get oxidation and reduction from the oxidation charge. All right, we keep moving. So let me check my time. All right, we still have time. So I have the next one. So the next question they gave us Fe2 plus Cl2 to give Fe3 plus 2Cl minus. Okay, this is very very simple. We know that Fe2 plus gave us Fe3 plus, and if you look at it, this is plus 2 increasing to what? Plus 3. So even if you want to check the oxidation charge, let us check the oxidation charge. Oxidation charge. The oxidation charge is simply the product minus what? The reactant, which will give you what? Plus 1. Let us check the other one. Cl2, okay, gave us Cl minus, gave us 2Cl minus. So this was 0, and then I'm having here minus 2. So let's check oxidation charge. Oxidation charge is simply what? Product first, which is what? Minus 2. Then minus reactant, which is what? Minus 2. And I told you that what? Positive oxidation charge is what? Oxidation. So this man is oxidation. Why this man? Negative oxidation charge is what? Reduction. So from here, we can now see that what? The one that the reactant of oxidation is called oxidized species. Please, no, don't go with agent. Oxidized species, as well as what? Reducing agent. So if you don't want to call it oxidized species, you call it reducing agent. So now, this one that undergoes reduction, sorry, so this one is reduction. So this one is now called reduced species, as well as oxidizing agent. While the right hand side, the product is called what? The oxidation product and reduction product. All right. See, this is very very simple, very very simple. So the next one we move to, the next question here said they gave us Cu plus Ag plus to give Cu2 plus Ag. Okay, this one is very simple. So which means Cu gave us Cu2 plus. So from 0 to plus 2. So let's check oxidation charge. Oxidation charge. Oxidation charge is simply from product which is 2, then minus the reactant 0, which is what? Plus 2. Okay, let's check the other one. Ag plus gave us normal Ag, that is from plus 1 to 0. So let's check oxidation charge. Oxidation charge will now be from product 0 minus reactant, so which will give us what? Minus 1. So therefore, positive oxidation charge is oxidation. So this man is oxidation. Negative oxidation charge is reduction. So this man is reduction. So now, from the left hand side, this one that undergoes oxidation is called what? Oxidized species. If you don't want to call it oxidized species, that is when you will now call it reducing agent. All right. This one that undergoes reduction is called reduced species. If you don't want to call it reduced species, you call it what? Oxidizing agent. This is very very simple. This is very very simple. All right. So let's check the next one. The next one here, they gave us that Cr2O7 2 minus plus NO plus NO2 minus to give 2Cr3 plus NO3 minus. Okay, so now we want to see what happened here. Problem. I'm seeing that this one lost oxygen. Look at it. Even without calculating anything, this one lost oxygen. It has oxygen here, and here there is no oxygen. So lose of oxygen, oxidation is gain of oxygen. So lose of oxygen is now reduction. I think this one undergoes reduction. Yes, very, very correct. And you see that this one, the oxygen here was 2, and then coming here became 3. He gained oxygen. So for gaining of oxygen, this man is what? Oxidation. But let us calculate it using our oxidation charge. Okay. First of all, we need to know the oxidation number of this man, Cr. Let us calculate it. Normally, we have that 2Cr plus what? 7 oxygen is giving us the charge here minus 2. So therefore, 2Cr plus 7 into, don't forget that this man is minus 2 is equal to minus 2. So therefore, 2Cr minus minus 14 is equal to minus 2. So therefore, 2Cr is equal to minus 2 plus 14. So therefore, 2Cr is giving me 12. So Cr is giving me what? That is plus 12. That is plus 12 divided by 2, which is what? Plus 6. You see what happened? See what happened here? That Cr2O7 2 minus the oxidation number of Cr here is plus 6. But moving to this side, he gave us 2Cr 3 plus. So the one, this one is here is 3 plus. So let us now check the oxidation charge. Oxidation charge. Oxidation charge here will now be equal to what? Product first plus 3 minus the reactant plus 6. So what do I have? Minus 3. You see? And I told you that what? Negative oxidation charge is what? Reduction. So this man, even he lost oxygen self, is even obvious that it is reduction. All right. So let us do the same thing for the other person. Let us do the same thing for the other person. Now, we need to know the oxidation number of nitrogen here. Okay. So we have that what? N plus what? 2 of oxygen is giving us minus 1. So therefore, N plus 2 of minus 2 is giving us minus 1. So therefore, my N minus 4 is equal to minus 1. So my N here will now be minus 1 plus 4, which is what? Plus 3. So I have that what? Let us do the same thing for this one. Please permit me to write it here. Permit me to write it here. We want to calculate for this one that N plus 3 of oxygen is giving me minus 1. So therefore, N plus what? 3 into minus 2 is giving me minus 1. So N minus 6 is minus 1. So therefore, my N will now be what? Minus 6, sorry, minus 1 plus 6, minus 1 plus 6, which is what? Plus 5. Okay, so look at what happened here. That NO2 minus gave us NO3 minus. And this one here is plus 3. Why this one here is plus 5? So let's take oxidation charge. Oxidation charge. Oxidation charge is equally from product plus 5 to what? Minus the reactant plus 3, which will give me what? Plus 2. You see, it is even obvious that he gained oxygen. But apart from gaining oxygen, you see that positive oxidation charge means what? Oxidation. So this man undergoes or undergone what is it called? Oxidation. And I told you that what? The reactant of oxidation is called, the reactant of reduction is called reduced species. If you don't want to call it reduced species, that is when you call it what? Oxidizing agent. Okay. Then the reactant of oxidation is called what? Oxidized species, as well as what? Reducing agent. While the right hand side, the product is called the reduction product, or you call it what? The oxidation product. All right. This is very, very simple. So let's move to the next one. And I think that will be the last question we'll solve for this particular one. Then we'll move to the next thing. So I have that what? MnO4 minus plus SO plus SO2 plus SO2 to give us Mn2 plus SO4 2 minus. Okay, so now see what happened here. It is obvious that this one had oxygen initially, losing his oxygen, and loss of oxygen is what? Reduction, because gain of oxygen is what? Oxidation. This man's oxygen was 2, coming here became 4, so he gained oxygen. Since he gained oxygen, this reaction is what? Oxidation reaction. But I don't want to get it from there. Let's get it from our oxidation charge. Okay, now we need to get the oxidation number of Mn here. So we have that what? Mn plus 4 of oxygen is giving us -1. So Mn plus 4 into -2 is equal to -1. So Mn minus 8 is equal to -1. So Mn is equal to what? -1 plus 8, which is what? +7. And the positive oxidation charge is called oxidation. Right? This one, he lost. Okay, sorry, that is not our oxidation charge. I was very, so I have that. This is so let us now write it. Our MnO4 minus gave us, I became afraid, gave us a Mn2 plus. So we calculated this one to be +7, while this one is +2. So our oxidation charge is equal to what? Product first +2 minus reactant +7, which is giving us -5. You see, negative oxidation charge is oxidation. So therefore, this is is reduction. So this is reduction. Very simple. So let us do for the other guy. For the other guy here, we need to calculate. For sulfur here. Yes, for sulfur here. So for S here, for the right hand side, I will have that what? For SO2. Or let me write it here so that you can see it. Let me just do it here. For SO2, there is no charge. I'll have that what? S plus what? 2 of oxygen is equal to 0 because there is no charge. So I have that S plus 2 of -2 is equal to 0. So S minus 4 is equal to 0. Therefore, S is equal to what? +4. Right? So let us still calculate for this one here. So I have that what? For SO4 2 minus, I have that what? S plus 4 into 0 is equal to minus what? -2. So therefore, S plus 4 into -2 is equal to -2. So S minus 8 is equal to -2. Therefore, S is equal to what? -2 plus 8, which is equal to what? +6. So let us now check their oxidation charge. Oxidation charge will now be from product, which is +4. Okay, who is the product? Sorry. So let me write the equation here. SO2 gave us SO4 2 minus. Okay, the product. So this is equal to the product here. We calculated for the product as +6 minus what? +4 to give us what? +2. You see, positive oxidation charge is oxidation. So these people is what? Oxidation. So the reactant of oxidation is called what? Oxidized species or reducing agent. The reactant of reduction is called reduced species or oxidizing agent. So that is that. So write for me the last one. Note, positive oxidation charge means oxidation. Okay, the reactant of positive oxidation charge is called oxidized species or as well as reducing agent. Okay, the product of the positive oxidation charge is called the oxidation product, while the negative oxidation charge is reduction. The reactant of negative oxidation charge is called reduced species as well as oxidizing agent. Okay, and the product of negative oxidation charge is called the reduction product. So in our next video, we will now talk about balancing of redox equation. Balancing of redox equation. So that's what we'll talk about in our next video. Please, 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 if you like this video, please subscribe, like, comment, and share. Bye bye. We love you.